When testing web APIs, it's often useful to have test data that is reseeded on every individual test run. In this section, we'll look at best practices for working with seed data. To get the most reuse out of your seed data and to keep your test cases consistent, it's usually best if you can use the same seed data for every test. Or, if it makes sense to have different sets of seed data, be sure to organize your tests around these different sets of seed data so that you are sure that each one is working correctly. Next, you will want to make sure that your seed data is completely reset before each test executes. If seed data isn't reset, it can result in tests that work when run by themselves, but fail when run as a group. Finally, if you want to be able to run your tests in parallel, and any of them perform any changes to the data, then you need to make sure every test has its own isolated data store. This may be a challenge depending on what you're using for your data. However, if you can't use separate data stores per test, then you will need to run your tests one by one, and this can make your test runs take a lot longer. When you're writing tests and asserting that results match what you expect, it's always better to compare directly against your seed data if you can, rather than using magic numbers for counts and magic values for item properties. If you're running seed data in code, this is usually pretty straightforward. But if you're using an external data store like a database, you may need to run some direct data queries to fetch the expected data, store it, and then run your tests in order to compare the results with the expectations that you got from those queries. Of course, regardless of how you're seeding your data or where you're storing it, make sure you don't have real customer data in your test data. You shouldn't have any PII or personally identifiable information, and you definitely shouldn't include anything that could result in tests accidentally contacting customers. So that means no email addresses or phone numbers. Also, you should avoid having any real customer credentials in your test data, whether they're hashed or otherwise. Although your test data should look like production data, it absolutely should not contain any sensitive data that may be coming from your production system. If you're going to use shared data for tests that are running in parallel, make sure the tests are read-only and that the persistence store allows multiple concurrent access. If you don't, you may end up with intermittent test failures that could be difficult to pin down. If you're going to work with a real data store, Respawn is a popular open source package that can be used to quickly restore a database to a known state. It's often used during integration tests to ensure a database is reset between tests. I don't often use Respawn myself, but I know many developers find it useful. You can install it and learn more from the URLs shown here. Tests in one test class using XUnit are a part of a default test collection implicitly. By default, these tests in a test collection do not run in parallel against one another. Any tests inside of a test collection are run sequentially. However, tests that are in other classes will run in parallel by default. One easy way to make your XUnit tests run sequentially overall is to force them all to be in the same collection by using the collection attribute and a common name for the standard collection that you want to use. In this example, test 1 and test 2 will not run against one another in parallel, but will run sequentially one after the other. You can further configure XUnit and its parallel behavior with assembly-level attributes. You can specify that the default behavior should be to have a single collection for the entire assembly. This will prevent parallelization of the tests when they are run. So will simply disabling test parallelization. Another option is to use the XUnit configuration file where you can set options like whether the test assembly should participate in parallel execution against other assemblies. And you can simply disable parallelization for test collections, which will disable all parallelization in the assembly. Note that your test runner may override certain XUnit configurations or behaviors, So depending on your test runner, some of these may not work as expected, or you may need to use test runner specific options to ensure your tests don't run in parallel in your test runner of choice. We don't have time to dig more deeply into XUnit configuration or advanced usage, but you can learn more about it in the C# Unit Testing with XUnit learning path shown here. Remember to treat your tests just like your production code when it comes to keeping it clean and high quality. There are some common elements to most ASP.NET Core Web API tests that make good candidates for encapsulation or reuse using helpers. The first one is application setup, which we already saw how to do using Web Application Builder. Next comes using seed data, which may also be done using Web Application Builder or may involve other work communicating directly with a data store from the test project, like Respawn does. Another common task is creating models to send to APIs. Making this more streamlined and less repetitive is often a good way to improve your tests. Working with your API, it's tempting to use hard-coded strings for endpoint routes, but it's better to spend a bit of time creating route helpers, either as strings or methods that are able to build valid route strings. Finally, the work of actually making HTTP calls and deserializing the responses is usually several lines of low-level boilerplate code that can easily be replaced with a helper, sometimes along with asserting a particular response was returned, such as OK, not found, not authorized, etc. When creating models to send to your API, there are a couple of typical variations: ints and strings and primitives, which ideally you should store as variables with names, either in the test itself or as private read-only fields on the test class, and DTOs. Most of the time, DTOs can just be created inline, since they should typically support object initializers. However, more complex objects that end up taking many lines of code to define should be moved to use helper methods or can even use the builder design pattern. When using a builder pattern with your test data, you're able to have a more fluent syntax and can create helper methods that include default values as well as the ability to override those defaults easily with unique values for any given test. To learn more about using builders to create test data, check out my article and associated coding kata to help you learn 2 different approaches to implementing builders. Once you understand how builders work, if you don't want to have to write your own implementations every time, the popular AutoFixture library provides generic test builders and can often be used in place of your own builder classes. When we look at how to encapsulate routes, generally you want to avoid magic strings for these routes and in general in your tests. Instead, define route methods that can be used consistently across your tests to create valid routes. These helpers might only exist in your test project, or you may find it valuable to use them in your API project or client projects as well, especially if you're specifying full routes on each endpoint as opposed to using a standard convention defined when your app starts up. You can organize route helper methods into static classes by API resource so they're easy to find. In this case, I have a static routes class with another inner class that is the static authors class. I'm defining a variable called route here as a separate variable just for clarity, but in a real test, you can usually do away with the comments and then inline the route variable once you're certain that it's correct. Calling endpoints and deserializing responses often results in a relatively large amount of code. You have to define the route, you have to make the call to get the response, you have to make sure it was successful, you need to read the response as a string, and then finally you can deserialize the string into a type. This is a perfect candidate for extracting a helper method that will do a lot of this work for you. The helper method takes in a route and just returns a deserialized type, in this case an author DTO. Of course, you can create similar helpers for other methods, put, post, delete, etc., and you can make the helpers generic with respect to the return type, so that you don't need to create a new method for every different resource that your API uses. Since I write a lot of API tests, and my company NimblePros helps many clients to do so, I've published a set of extension methods as a NuGet package you can download from GitHub or add to your project using NuGet. It includes most of the basic helpers that you would need, and of course, you can request additional ones or add more as issues or pull requests if you like.